In this video, we're going to look at how to name cycloalkanes and how they're similar and different from naming alkanes. So cycloalkanes are compounds that are very similar to alkanes. They're all single bonds, but some or all of the carbon atoms are arranged in a ring. Now the 5 and 6 membered rings are the most stable. The smaller the ring gets, the more unstable it is and the more reactive that it's going to be. So notice cyclo, okay, so the prefix is cyclo, and this tells us that your alkane is going to be in a ring. So cycloalkanes have a general formula CnH2n. So notice it's not the same as an alkane, it's CnH2n. And you'll see once you start looking at the formulas and at the structures, you'll see why it's only 2n and not 2n plus 2 for the hydrogens. So cycloalkanes are named essentially the same as an alkane, but the name is based on the number of carbon atoms in the ring itself. So as you're looking at the cycloalkanes, it's going to be based on the number of carbons that's in the ring itself. So some examples. Cyclopropane. So this tells us we have propane, but it's in a ring. So cyclopropane looks like a triangle. Now you also might actually see cyclopropane written, pretend that's a straight line, like a triangle, like an equilateral triangle, because this is a C, this is a C, and this is a C. Remember, carbon wants 4 bonds. This carbon is bonded to this one, and this carbon is bonded to this one, so it only has 2 H's off of it. Methyl cyclopropane. So this tells us that our parent is cyclopropane, but we have a methyl group off of it. Now, the reason you don't see the 1 here is because it's assumed that the functional or that the substituent is going to be off of the first carbon when you number it. So methyl cyclopropane would be cyclopropane, which looks like a triangle, with a CH3 group off of it. Now you could do it up here if you wanted, you could do it over here, because you could rotate this and it could look the same no matter which way it went. Then you have 1,1-dimethyl cyclopropane. Now that we have 2 methyl groups, we're going to have to include the numbers. So dimethyl cyclopropane, so cyclopropane is going to be your triangle again, and you're going to have 2 methyl groups off of the same carbon. Okay, so then if we have 1,2-dimethyl cyclopropane, again your parent is cyclopropane, so you're going to draw out cyclopropane, and then 1,2-dimethyl, so 1 methyl group, 1 methyl group. Then we have cyclobutane. Cyclobutane looks like a square. It's 4 carbons, all single bonded, in a ring structure. Then you could have methyl cyclobutane. So again, we don't include the 1 here because it's assumed that it's going to be off the first carbon as you're numbering.